Hello, this is Mr. Chang, and we are doing Math 20-1, Unit 1 on Sequence and Series, and we are on Lesson 5. All right, now we've done Lesson 1 to 4 is about arithmetic sequence, and now Lesson 5 to 7 is about geometric sequence. And then the layout of the lesson is very similar. First, derive the formula for the term, and then derive the formula for the sum. So very similar, okay? And then they're very similar question as well. The only differences is lesson 2 to 4 is arithmetic and now it's geometric. So what's the difference between the two? If you look at the following sequences, 2, 4, 6, 8, you are adding a common difference every time. If you are adding or subtracting a common difference, is arithmetic. And look at the second series, 2, 4, 8, 16. You're multiplying by 2. So if you're multiplying or dividing by a constant, it is geometric. All right. So very straightforward. So just keep in mind, whenever you have a question, just ask yourself, is it arithmetic or geometric? If it's given in the question, then you know, right? If it's not, you just need to figure that out. All right, geometric sequence, you multiply by a constant. So if you have 3, 6, 12, 24, how can you find out the common ratio? For geometric sequence, we don't say common difference, which we use letter D. In here, we use common ratio, okay? Because you divide two numbers. For example, the common ratio here is 2. Where do you get 2 from? Well, because 6 divided by 3 is 2, or like 12 divided by 6 is 2. Just take any term divided by the preceding term. So the formula we wrote is you just take any term Tn divided by the previous term, which denoted as Tn minus 1. Then you have the common ratio. We use a new variable called R. In the example above, the constant is 2. The common ratio is 2. All right, so after we define what is geometric sequence is, now we can look at some example. All right, so all of the following are geometric sequence because you times 2 every time. It's times 2 is times 2. So the common ratio is 2. When the common ratio is bigger than 1, your list just get larger and larger. All right, how about this one? -1, 5, -25, 125. What happened? Well, you multiply by -5 every time. For arithmetic sequence, if the common difference is negative, the sequence gets smaller and smaller. But for geometric sequence, if it's a negative, it doesn't get smaller and smaller. It's alternate. Alternate from negative, positive, negative, positive. So we alternating. Alternating sign. Okay, when we deal with geometric. So how can you get the number getting smaller and smaller? Well, look at the third example. All right, the number gets smaller, like if you ignore the negative, the number gets smaller, 10, 5, 5 over 2, 5 over 4. So what happened? You divide by 2 every time. What's the other way to say divide by 2? Is you multiply by half. Okay, so the common ratio is half. You multiply by half every time. Then the list is decreasing in values. When the common ratio is bigger than 1, is increasing in values. Okay, and then the following like is you can look at are they geometric or not. Okay, so very simple. This one you multiply by 3 every time. This one is not. This one you minus 36 every time. So it's arithmetic sequence. D is -36, so it's not geometric. And finally, this one will happen. How can you find out the ratio? You take any term divided by the previous term. 2 over -3, which means -2 over 3. And then you try the second one, like this one divided by that one, is it -2 over 3? The answer is yes. And then take this one divided by that one, it is -2 over 3. So this is geometric. Okay. All right, let's look at the formula. Okay, once we know what's geometric, and now we want to have a quick way to determine the term. Okay, so investigation number 1, just like what we did with arithmetic, we show the pattern and then find out the formula. Okay, in here, the pattern for geometric is everything is multiplying. So look here. You start with your first term, you multiply by your common ratio. For the third term, you multiply by a common ratio twice. For the fourth term, you multiply by the common ratio 3 times. So the term number and then the number of times you multiply by the common ratio is always off by 1. So the fifth term is AR4. How about n term? Is A times R to the power of how many? 1 less than the term number, n minus 1. Okay? I hope you see the parallel with arithmetic. Arithmetic will have A plus D, instead of like here is A times R because it's geometric. Here, arithmetic is adding. And then when you add 2D, is like multiplying. It's like 2D, and then 3D, and then 4D, and then you have a n minus 1d. So everything is a plus, and then when you're adding many terms together, it's multiplying. In here, everything is multiplying. When you multiply many terms together, it's exponent. Okay, I hope you see the parallel here. We use the same symbol for term number Tn. Okay, it just means the term number. It could be geometric series, a term in a geometric series, or a term in arithmetic series. Let's look at the general term. Okay, so we have the formula. Here we go. Tn is a to the power of r, a times r to the power of n minus 1. Okay, when you evaluate it, make sure you do the exponent first, because that's bad miss, and then you multiply by a. All right, example. All right, how do you find Tn? First, you find out a is the first term. Common ratio is any term divided by the previous term, so it's 3. And then you have 9 terms. Okay, 9. So what's the 9th term? Is a, r, n minus 1. Okay, and then what you need to do is you need to put the 3 to the power of 8 in the calculator first, and then multiply by 5. All right, so do 3 to the power of 8 first, which give you a huge number. And then finally, you multiply by 5. Geometric growth, because you're multiplying numbers, so the sequence can grow very quickly. All right, here a is 1/3. R is, you take any ratio divided by the previous one. Okay, how do you divide fraction? You multiply by the reciprocal. You multiply that by the reciprocal, so you find it's negative 1/2. Okay, n is 7. So now it's a matter of plugging it all in. A times r negative to the power of 7 minus 1. Okay, once again, evaluate the bracket first. So the answer is 1 over 64. Okay, and then final answer 1 over 192. When you bring negative to the exponent of 6 to an even number, it's become positive. All right, now we're moving on, and like we have some like example here. Another question: how can you do the following? If I give you a, I give you common ratio is any term divided by the previous term, which is 2. I can write the general term. Okay, general term, I don't need to know n. So I just write 32 times 2 ar n minus 1. Okay, so that is my answer. Now, normally, that's it. You're done. You can't simplify this one. Okay, because you can't multiply first. It's bad miss. So you cannot. So the only thing you can do is leave it in this form, exponent first. Usually, that's the answer. For this one, it so happened 32 is a power of 2. Then you can simplify this into 32 is a power of 2 to the power of 5 times 2 to the power of n minus 1. When you work with exponent, you can add the exponent together. Okay, that's the only time you can simplify it. And then it becomes n plus 4. Okay, so that's the simplified expression for this question. Otherwise, let's say if you have Tn equal to 3 and then 5 to the power of n, right, minus 1, you can't simplify it. Okay, you cannot. You cannot put the 3 and 5 together. 15. No, don't do that. Okay, it cannot be simplified. Only for this special case you can simplify. Now, let's solve it. We want to solve for n. Okay, well, they give you the last term. Remember, what's the symbol for last term? Is Tn. So let's put it in our formula. A lot of people, right, just write Tn equal to a r n minus 1, and then they don't know what to do because there's two unknown. N is unknown, Tn is unknown. Well, Tn is not unknown. Tn is known, so don't put Tn there. Put the actual term there. Okay, the last term can also be the Tn. Now, it's a matter of solving this equation. How do you solve this equation? The first step is get rid of the 32. Okay, 5, 1, 12 is 2 to the power of n minus 1. The pen is acting funny. All right. Okay, boom, magic. I fix it. Okay, now the words is okay now. Now, for this one, you can only do guess and check. You can't put this in a calculator because you don't know the exponent. Let's say you know the exponent is 7, then you can take the 7 roots of 5, 1, 12. But you don't know. So there's no operation you can do here, okay? Actually, there is, but the operation you're going to learn in grade 12. So you can't do it now. So you can only do guess and check. The nice thing is the number won't be too big, so you can just keep trying. Okay, 2 to what power give you 512? Okay, the answer is 9. 2 to the power of 9 give you 512. So if 2 to the power of 9 give you 512, and the exponent is n minus 1, which means the exponent are the same. Therefore, what n value give you a 9 there whenever n is 10? Okay, so for this question, the answer is 10. There are 10 terms in this sequence. Or like 163A4 is the 10th term for this sequence. All right, so once again, you use guess and check for this question. All right, let's move on. So we are not going to do the graphing calculator. Geometric means. All right, so just like the arithmetic means, do you remember? Arithmetic means is when you insert numbers in between two numbers so that you are forming a arithmetic sequence. Now, geometric means is the same thing. You insert numbers in between two numbers so that the whole list is become geometric. All right, the question say insert 4 geometric means in between there. Okay, between there and there, I insert 4. 1, 2, 3, 4. Okay, so let's solve it. What do I know about this one? This is A. What do I know about this one? This is Tn. What do I know about anything else? You think you didn't? Actually, you do. This is not Tn. This is actually T6. Remember we did that with arithmetic sequence? Okay, because we actually know the number of terms. There are 6 terms. You have two n's and then you add 4 terms. 4 plus 2, there are 6 terms. All right, we have everything we need except we don't know D. So let's solve for D. Tn is A, sorry, R to the power of n minus 1. Okay, what's the first step? So 1 over 729, you divide by 81. Okay, turn it back to a fraction. And then you find out, oh, it's too small to turn into a fraction. But if you just divide the number, is this much. Okay, equal out to 5. And then what happened is, well, this is, you don't need to do guess and check because you know the 5. It's 5 power, definitely. You know what's the exponent. So to solve for out, you take the fifth root of this number. Wow, okay. The calculator will let you do that. The calculator will do that for you. So you don't need to do it in your head. Okay, so the answer you will get is 9. So the common ratio is actually 1 over 9. Okay, so from 81 you times 1 over 9. Okay, from 81 you times 1 over 9. Ignore the line, the computer is acting weird. Times 1 over 9 you get a 9. Okay, all right, let's try again. 81. Okay, so 81, and then you do 9. Okay, don't worry about that. So 81, the common ratio we find is 1/9. So 81 times 1/9 is 9. Times 1/9 is 1. Times 1 over 9. Times it again. And times it again. That's what you get. All right. Okay. And then finally, we move to the last type of question. Okay. Remember, we have something like that in arithmetic, right? You have 3 terms. 1, 2, 3. They form geometric. Just like arithmetic, we take the difference to find out the common difference. Now, for geometric, we take the ratio to find out the common ratio. The ratio is any term divided by the previous term. Okay? Term 2 divided by term 1. Also, you can do term 3 divided by term 2. In order to be geometric, you just make them the same. Now you solve this equation. Okay, I'll solve it here for you. Okay, I'm showing all the work here. Basically, you cross multiply, you get this, and then you FOIL, and then you solve it, you get the answer. And then you plug in the numbers, it will give you geometric sequence. All right, so I think I'm going to stop here. There was one more example, but we can do it in the future. All right, so hopefully you have a good class and enjoyed this class. See you later.